All right, let's go ahead and talk our way through these, and then we will dig into notes in your book. I'm going to clear out what we've got here. So if I do negative 12 plus 5, what does that come out to be? Negative 7. It's been a whole summer, in case you don't remember, or in case you've always kind of struggled with negatives. They still kind of throw me sometimes too. When we're working with negative numbers, or anywhere on a number line, if you are adding, you're going to be moving to the right. If you are subtracting, we're going to move to the left. So I'm at negative 12, and it tells me I'm going to add 5. So 1, 2, 3, 4, 5. And that's how we get that answer of negative 7. The next one down, number 2, I'm adding a negative number. Let's see if we can simplify that symbol a little bit. When you add a negative, it's the same as what operation? I'm sorry, what did you say? I just didn't hear. It's the same as subtraction. When we subtract a negative, it turns into addition because I have a minus and a minus. That turns into a plus. But when I have a minus and a plus together, that stays subtraction. So this is the same thing as negative 4 minus 1. So I would start at negative 4 on the number line. And then even though it says adding, because I'm adding a negative, I would go to the left 1 space. So this is going to simplify and give me what? Negative 5. What about positive 12 plus negative 7? How would I simplify that so that I don't have plus and a negative there? It'd be the same as what? 12 minus 7. So 12 plus negative 7 or 12 minus 7, same thing. How does that simplify? Positive 5. Negative 8 plus 11. 3. And then the very last problem on the bell work today, they ask us to find the average. How do you find the average when they give you a bunch of numbers like this? What do you do to find the average for something? That's absolutely correct. We're going to add them all up, and we're going to divide by however many numbers they gave us. So we're going to take 2. We're going to add that to negative 1. We're going to add that to negative 3. We're going to add that to 4. And we're going to add 3 onto that. So we add all those together, and then we're going to divide. What are we dividing by in this case? 5. They gave us information for 5 days, so we have 5 numbers we're going to divide by 5. How does this simplify? What do we get when we add up the top? Let's see, 2 plus negative 1. What's 2 plus negative 1? It'd be the same thing as 2 minus 1, right? 1 plus negative 3, so 1 minus 3, negative 2. Negative 2 plus 4, 2. 2 plus 3, 5. So when we add up the top, we get 5. Can somebody pull out a calculator and double check that for me just to make sure we did that right? Yes. Those calculators are stuck there. I can pull some other calculators out, though. Would you like me to pull a calculator? Absolutely. More than happy to. Does anybody else want to use a calculator? All right. Feel free to come up and grab one if you would like a calculator. Did we add up our numerator correctly? Yes, ma'am. What'd you say? I'm sorry, I can't hear you. I can't hear you over the little thing over there.
So I was going to say this.
Oh, what'd you get?
5 over 5.
5 over 5. Yes, our numerator is 5. Our denominator is 5. Can we simplify 5 over 5 at all? What does that simplify to? 1. And then since we're looking at a problem in context, do we need to put units on that 1? What would the units be? Degrees. In this case, it would be degrees Fahrenheit. So that would be my final answer here. Awesome. Very nice work on that. Your warm-up on Monday is going to look very similar to this. We're just going to practice with some number sense. We're just beginning to dig into some geometry stuff, so I'm not going to give you warm-ups that are focused on that until we have a little bit more under our belt. Most of the time, I have you guys do warm-ups on pages that I provide for you, and then you'll turn them in on Fridays. Since yesterday was our first day and today is Friday, I'm not going to collect it this week, and it seemed kind of silly and wasteful for me to print off a whole piece of paper just for today. But on Monday, you guys will pick up a new warm-up or bell work page, and that's what you'll do your bell works on, and then you'll submit that on Friday. We won't necessarily have one every single day, but I'll have a space on the page for every single day, so that when we have them, you can write those down and then turn them in for me. Let's go ahead and dig into your books for right now, though. We're going to start off on page 11. And like I kind of talked about yesterday, vocabulary is so important in geometry. We're going to start off with some basic vocabulary that we have to understand. We have to make sure we've got this down because this is foundational for what we're doing in the geometry classroom. The first 3 vocabulary terms that we're going to talk about, and some of these may have surfaced yesterday in our activity, are point, line, and plane. We consider point, line, and plane to be undefined terms because while we can come up with a definition for them, most people already understand, especially after Algebra 1, what we mean by a point, what we mean by a line. And even though plane might feel a little bit unfamiliar, you have worked with them before, and I'll let you know how here in just a minute. In Algebra 1, if you were going to plot a point, how did you do that? Like, tell me, you have your pencil and your paper, you're supposed to plot a point, what do you do? How would you plot a point? What kind of thing would you draw? A dot. Depending on what the coordinates of that point are, you're going to count over and up or over and down a certain amount, and then you're going to put a dot there. A point represents a location in space. When you did it in Algebra 1, it represented a location on that grid, on that XY grid. A line. You guys drew lines in Algebra 1? When you went to go draw a line that you were supposed to do for an assignment or a test or an example in class, what was the fewest number of points you had to plot before you could grab a straight edge and draw that line in? 2. You have to have at least 2 points if you're going to draw a very specific line. A line does what in both directions? Keeps going. How did you represent that when you drew them? Arrows. You draw arrows on the ends of it to represent that it goes on forever and ever and ever. In geometry, that's going to be really important. In algebra, sometimes they let you get away with not putting the arrows on the ends. They're like, well, we know that you mean that it goes on forever. But in geometry, if you leave the arrows off, it actually means something different. So when we graph lines, we've got to put the arrows on either ends because if we don't, we're talking about a different type of thing. Some things in geometry, we can be a little bit squishy on, we can be a little fuzzy, your way can be a little bit different than mine, and that's okay. And there's other places where we have to make sure that we are super precise, because if you call it this, you're talking about something different than when I call it something that looks very similar, like a straight line with no arrows and a straight line with arrows. In geometry, those are 2 different things. In algebra, it doesn't really matter that much. A plane. Who's ever heard of a plane before? Not like an airplane. You've heard what? Heard of it before? you want to share what you know about it or no? You've heard of it. Fair enough. That's 100% valid. So a plane, when you guys would graph on your X, Y grids in Algebra 2, got mine on my whiteboard right here. It doesn't have the X, Y axis, but I've got the grid right here. Does anybody know what that kind of a grid is actually called? What the formal name for an X, Y axis with the grid in the background is called? It's called a coordinate plane. Coordinate, because when you go to plot a point, they had to give you two numbers, the X number and the Y number. Those were the coordinates of the point that you were going to plot. And a plane, because it was a flat surface that extends in all directions. As long as it stays flat, it extends in all directions forever. Did you guys graph on graphs this big for all of your Algebra 1 lines? Did you draw on smaller ones? Could you have drawn on bigger ones, like the size of my blackboard, if you had wanted to? Absolutely. Planes go on forever in all directions. We can have really big representations. We can have very small representations. But we know, no matter how big or small we draw that plane, that it continues on forever and ever. And if you look at an XY axis, a coordinate plane, they've got arrows on the y-axis and arrows on the x-axis to show that that whole thing continues on and out. All right. Let's talk about how we name these things in geometry. A point in geometry gets named with a capital letter. So they have an example for us over here, the point A. Notice it's just like a normal capital letter, like a print or like a computer, a typewriter would make, just a normal capital letter A. In algebra, a lot of times when you would label your points, you gave the X and the Y coordinates. In geometry, we almost always name them this way with just capital letters. A line is made up of points and has no thickness or width, but it continues on forever and ever in both directions. So they have an example of a line over here. They have this point, which they've named what? Point P. And then they've also named this other point over here, and they called it what? Q. So point P and point Q. Not a trick question, but almost, so think before you answer. They named point P and they named point Q. Are those the only 2 points that could ever be on this line? Are those the only points that are on this line? It's actually a no. Because we could plot other points on this same line, even though we don't have them named, that's what we're representing by connecting those together with our pencil. If I show all of the points that are on this line, do you see how when I draw them in there, they start to run together and it starts to look solid because they're so close together and on top of each other almost? That's why we use our straight edge instead of drawing in all those little points on there. So there's an infinite number of points on this line. We only know the names of 2 of them. But there's lots and lots of points that are actually there. Does that make sense? Okay. So we have a couple different ways of naming lines. With points, we only have one way of doing it. Capital letters, that's it. With lines, we can either give them a lowercase script name, so this is a lowercase script M. Do you guys know what they mean by script? It's another way of basically saying cursive. So it's supposed to be like a cursive M. I don't like the way the font in your book tries to show cursive because I don't think it looks very cursive-y or scripty. So I usually make mine a lot more loopy so that it looks like a cursive M. So we can name our lines by writing the word line, L-I-N-E, and then using a lowercase cursive letter. So I could call this line little m. Line M. The other way that we can choose to name a line is by naming some of the points on the line. You guys just told me a moment ago, when you draw a line in Algebra 1, what's the smallest number of points that you have to have in order to be able to pull out your straight edge and draw between? You have to have 2. When we name lines with points, we use 2 and only 2 letters to name that. Even though there's a ton of points on there, we only give the names of 2 of them, because mathematicians like to get away with the least amount of writing possible, and so we name it with just those 2 letters. If I'm going to name it with the points on the line, I've got 2 possible ways of doing that. I can write the word line, L-I-N-E, and then I name the points that are on that line, P and Q. Remember when I told you mathematicians like to get away with the least amount of writing possible? If you're looking at a picture that has a lot of lines, they don't want to write the word line over and over and over and over and over. So they came up with a symbol that they can use instead. So the other way that we could write this is to name those 2 points, P and Q, and then over the top of those 2, we put a little symbolic line with arrows pointing either way. So capital P, capital Q, with a line with arrows over the top of it. Point P is on this line, right? And point Q is on the line? Would it have mattered? Would I be talking about a totally different line if when I walked up to the board I started reading it this way and I said, oh, point Q is on this line. Oh, and point P is on the line. Does your answer change? No, if I read it the other way around, they're still both on the line. When I name the line, it does not matter which order I put the letters in, just as long as I have 2 points that are on that line. So I can name it like this, line PQ, or I can switch those letters around, and I'm still talking about the exact same line. I can call it PQ, or I can call it QP. I can write the word line in front of it, or I can put the symbol over the top of it. Or I can represent it with that lowercase cursive letter. So far, so good? All right. One more type of object that we're going to talk about. When we looked at those 3 vocabulary words in the paragraph on the previous slide, we had point, line, and plane. Let's talk about how we name a plane. A plane is a flat surface made up of points that extend infinitely in all directions. Could I draw 2 points on here with my dry erase marker? If I had my dry erase marker, I could draw 2 points on here. Could I draw 3 points on here? Would it be possible for me to draw 3 points on here that I couldn't use a straight edge and draw 1 line and hit them all? Is that possible? Like if I put a dot here and a dot here and a dot here. When I name a plane, I need to use 3 letters. 2 letters is the smallest that I need for a line. So if I only use 2 letters, I'm only talking about a line. I need 3 points, 3 capital letters, if I'm going to describe a whole plane. But it's really important that those 3 letters aren't all on the same line, or else I'm just talking about a line with more letters. Does that make sense? So when we talk about a plane, we need to use 3 non-collinear, that's one of the vocab words that showed up yesterday, and we'll talk about that here in just a minute. Non-collinear means not all on the same line together. We need 3 non-collinear points. So this plane right here, I could name it as plane B, C, D. That's one name for this plane. Just like on the previous example when we were talking about lines and I could do PQ or QP, the order didn't matter on those. When I'm naming a plane, the order of those letters doesn't matter. Can you guys give me another name for this exact same plane using those 3 letters, but that looks different than what I just wrote? CBD. BCD. If you wanted to, could you come up with another one, or is that the only three? DBC. There's actually 6 different ways to do this by mixing up those letters in different orders. There's 6 different ways I can mix them up before I start to just repeat what I've already written before. Once we get out of Module 1, once we take this test, if I ask you to name a plane for me, you only have to give me one way of naming that. Or if I'm going to tell you about a plane, I'll use one way of naming it. If you name it one way and I name it another, but it's like this, we know that we're talking about the same thing. While we're in Module 1, as we're learning about how to name things and how to talk about objects, I am going to ask you, like on your first homework assignment, to give me all the possible ways you could name these things. To practice all those different ways so that you recognize them when we move forward as being the same thing. There's one other type of way that I can name a plane. Do you remember how with lines I could do a cursive M or a script M? Had to be lowercase though. With a plane, I can do the same kind of thing, and they have it shown up here. There's 4 letters that they show on this plane. 3 of them have something in common that the 4th one doesn't. What do 3 of these letters have that the 4th one doesn't? They have points. They have dots drawn next to them. Which one doesn't? K. This is not a point. This is a capital script letter. And remember, script is just another way to talk about cursive. I don't like the font that they used in your book for this. I try to make mine much more loopy looking so that it doesn't just look like a print K, because that is a point. That's something different. This is part of the reason why I do like the other notation for points. We use capital letters, but sometimes it's hard to tell the difference between cursive capital letters and just print capital letters. The other way I know for a fact whether it's a point or not is the point has to have the dot next to it. So if it has the dot next to it, it's talking about a point. If it doesn't have the dot next to it and it's a capital letter, they're trying to tell me the name that they've given to this plane. So we could also call this plane K. That would be another way of writing or naming this plane. With lines, I can put the line with the arrows over the top and I can cut out having to write the word. With planes, there's no shortcut like that. I have to write the word plane, P-L-A-N-E, and then I have to give the name of that particular plane each and every time. All right. 5 more terms on this page and then we'll actually get to practicing some things. So the first term that I want to talk about and define is space. A plane is a flat 2-dimensional space that extends in all directions forever, but it doesn't have any height to it. It doesn't have any depth to it. As soon as we add height and depth, I can go out in all 3 dimensions, length, width, and height. Then we're talking about space. Space is everything in 3 dimensions. Then we have collinear, non-collinear, coplanar, and non-coplanar. Collinear means all my points that I'm talking about are on the same line. I can take a straight edge and draw one line that goes through all of those points. So A, B, and C are collinear points. What about A, B, and D? Are those collinear? Could I take my straight edge and draw one line that goes through A, B, and D all at the same time? Since I can't take one line and draw through them all, we call them non-collinear. It means they're not all on the same line. Coplanar means my points are all lying on the same plane. Anytime you graphed in Algebra 2, you drew coplanar points because they were all on the same flat surface. If I had a bunch of points plotted here, and then somehow I managed to get a point up here hanging out in space, this one would be non-coplanar with the ones that are drawn down here, because they're not on the same flat surface as the other ones. Give you another representation. So if my piece of paper here is like a plane, if I have a point like up where the eraser is, it's non-coplanar. with everything that I would draw on the paper. So R, Q, and P are all coplanar points. Do they show in this picture anything that would be non-coplanar? What do you notice about S? It's script. It doesn't have what next to it? Doesn't have a dot next to it. So there they're just giving me one name for that plane. They can call it plane S. On this picture here, they're not showing us any points that are non-coplanar. If you flip the page though, in this figure, they do show me a point that is non-coplanar. That picture is a lot like what I was showing here. So this piece of paper is like that blue parallelogram that is representing plane A. And then they have a line going through that that's like my pencil right here. What point is on the line that is not on plane A? What point do they show you that is on a line? V. Point V is like up here. And plane A is like my piece of paper here. All right, so let's practice naming some things. When I name a line, I need 2 and only 2 points, or I need a lowercase cursive letter. When I'm naming a plane, I need 3 and only 3 points that can't all line up in a straight line, or I need a capital cursive letter. And when we name points, what do we need? Points. What do we need to name a point? Just one capital letter. One capital letter. All right, so we're going to talk about the line that is containing point Q. We can see that they call that line C. They have a lowercase c there. Which points did they name for us on line C? T, R, and Q. T, R, and Q are 3 points that they picked out and they gave names to. Are those the only 3 points that are on line C? Those are just the only ones that we know the names of. So we're going to use those 3 points, and we're going to give other names to this line. But how many letters do I use to name a line? Just 2. So one possible name that I could give to this line would be line TR. Because I could take my straight edge, I could draw a straight line through T and R, and it's also going to hit point Q over there. So there's one possible name for the line. When we were talking about this on the previous screen, I said the order of the letters does or does not matter. Does not. So instead of calling it TR, I could also call it what? RT. So I could call it TR, I could call it RT. I can call it RQ because Q is also on that line. What else could I call this? QR. I could call it what? QT. I'm going to pause here for just a second. The last 2 that I wrote have something wrong with them. Yes. I didn't add the symbol over the top. If you don't have the symbol over the top, then you have to write the word line in front of it, or else you're talking about something entirely different. So you have to remember to put the line over the top. All right. I think there's one more way that we could possibly name this. I've got TR, I have RT, I have RQ, I have QR, I have QT, TQ. I just drew that last one wrong. I wrote it down wrong. Why is that one wrong? I didn't add the arrows. Without the arrows, it has a different meaning. Putting the arrows over the top is super important when I'm talking about lines. Just stay with me, dear. Sit up. All right. So that's all the different possible ways that I could name line C using the points that they've given me. Could I add more names if I decided to name another point over here and I called it W? Could I now have more names for that line? I could have a lot more names. I could do WT, TW. I could do WR, RW. I could do WQ, QW. I could have all those different names added on if I added another point on there. How can I name planes again? 3 different points. And what can those 3 different points not do if I'm going to name a plane? They can't all be in one straight line. So I can't name this plane TRQ because TR and Q are all on the same line together. We can name it with a capital script letter like they have down here in the corner, so we can call this plane A. They have 2 names for it, plane TRS, plane TQS. They've got 4 options right here. Which of those, 1, 2, all 4 of them, 3 of them, which of those could I use to name this plane? QST. What's wrong with the other 3? V is not on the same plane with the other points. Are these 3, TRS, TQS, QST, are those the only 3 ways that I could name that plane? Can you guys think of any other way that I could name that plane and still be talking about the same space? RTS. STQ. QTS. We could keep going with this one. Remember, I have to put plane in front of it if I'm talking about a plane, but we could go on and on and on with ways to name this plane. Important things to remember is we have to have how many letters for a plane? 3. And what has to be true about those 3 letters? Can't all be on the same line. The reason for that, you guys can see my really bad model that I made last night. So here I have 2 planes that are intersecting each other. I've got this plane down here, and then I've cut through it with this plane right here. If this is like my plane A, like that blue parallelogram up there that they're using to represent plane A, I could have point T, point R, and point Q that are all right here. They would be on plane A, but they would also be on this plane because that's right where those 2 are crossing each other. That's why they have to be not all on the same line together if I'm going to describe a single flat space. All right, let's look at some everyday objects and how you see some of these geometric ideas represented or modeled by everyday objects that we have. This composition notebook here, if I look at the whole notebook, does that remind you more of a point, a line, or a plane if I look at that entire flat notebook? A plane. For the next question, your book actually has a little bit more than mine does. I pulled this off of the online workbook that's supposed to be exactly the same as yours, but mine only has line JK and then it has a blank. Yours has another one written in there. Line KL. So we have line JK, that's this line right here. We have line KL, that's this line right here. That's if I just look at the edges of the notebook. Do you guys see another line that's modeled by an edge of this notebook? J what? JN. And I actually see one more. They just didn't draw the line in for me. Is there another place, another part of the edge where we could draw a line in, but they just didn't? LN. So we also have line LN. I need a little bit more space for that. So they could have drawn that line in down here across the bottom. The quarter, right up here. This models point what? What name did they give that point in space? M. These two last questions and then we'll wrap it up for today. Points N, L, and K, and your book doesn't really give what they're looking for here. I'll let you know. I want either collinear, non-collinear, coplanar, or non-coplanar. So when I look at N, L, and K, which of those terms fit? Coplanar. They are all on the same plane together. Are they collinear? Are they all on the same line together? So we could also say non-collinear. Coplanar is going to be what your book, what the tests and quizzes are looking for. We want to be as precise as possible. But if they're coplanar and not all on the same line together, we could also say they're non-collinear. What about P, Q, and R? Collinear. Are they all on the same flat space together? So we could also say that they are what? Coplanar. They are all on the same flat space, so we could say they're coplanar. Collinear is more precise. 3 points that aren't all on the same line together can be coplanar. If they're all on the same line together, the more precise way of saying that is collinear. All right, very quickly before you guys leave, your first homework assignment's not due until Tuesday. You do not have to get started on it right now, but if you want to start working ahead, if you feel comfortable and confident to start on the homework, here's what it is. It's pages 15 through 17, 1 through 7, all of them, 8, 13, 15, 17, and 18, 25 to 28, all of them, 35 to 40, all of them. That feels like a lot of problems, but most of them are just real quick one word or one symbol answers. When you turn your homework into me, it's going to be ripped out of your book and then stapled together. So if you want to rip it out of your book and take just that part home, you're welcome to do that. Just don't lose it so that you have it ready for you when you need to turn it in on Tuesday.